So right here we have an example of using U substitution, and I say level 2 because one of my favorite professors I had in math used to say, okay, let's level up. So kind of showing, you know, beginner, intermediate, and difficult levels, that kind of thing, to kind of show this the step ups and some of the same strategies we use. So we've used U sub before, but there's just a slight increase in the extra step required here, so I'll call it a level 2 U sub. And the integral we're going to deal with is x over the quantity 2x plus 1, all of that cubed in the denominator, dx. And of course, now they decided to do the yard work across the street, so we'll ignore that. So on this integral, I'm thinking U sub because of that power. But the reason I'm thinking it's a level 2 is because of that extra x in there. And I'm looking at when I make a U sub of that 2x plus 1, and I take the derivative, I'm going to just get a 2. So that x is going to still be hanging out. And so when I tried this, I go, wait a second, I'm left with this x. What do I do with this? So again, that's why I consider this like a level 2 U sub. And I say, all right, let's go ahead and let u equal 2x plus 1. And then that means du equals 2 dx, and okay, 1/2 du will equal that dx. And so then I have my replacement for dx, but then I look, okay, I still have this x that's going to be left over. So my u substitution of 2x plus 1, I could rewrite that as u minus 1 all over 2 equals x. And that's because I subtracted 1 to the left side of my original expression, original equation, and then I had u minus 1 equals 2x, and then I divided each side by 2. So now I have enough here to make all the substitutions I need. So making all the substitutions, x becomes u minus 1 over 2. The denominator becomes u cubed, and that 1/2 from the 1/2 to u, I'm going to stick out all the way in front, and du. So everything's in terms of u, and then I just have some constants running around there. Now this u minus 1 over 2, that could be written as 1/2 times u minus 1. So if that could be written as 1/2 times u minus 1, I'm just going to bring that 1/2 out in front with that other 1/2. That'll make it 1/4 out in front. And then just a u minus 1 in the numerator and u cubed in the denominator, du. And again, because my fractions, if I have a plus b all over c, that's equal to a over c plus b over c. I'm going to utilize that, and I get 1/4 all the way out in front, so I'm going to put a big bracket there. And then u over u cubed, so I'm doing a couple steps here. U minus 1 over u cubed equals u over u cubed minus 1 over u cubed. But for my antiderivatives, it's easier to just write these. So this is 1 over u squared minus 1 over u cubed, but writing them as a negative exponent's easier. So this whole expression inside the integral will become, so 1 over u squared will be u to the negative 2, and then this is minus u to the negative 3, and of course the plus c hanging out. And, oh, these are still integrals. And now I'm going to take the antiderivative, so no plus c yet. Got ahead of myself there. Now I want to take the antiderivative, so I'm going to add 1. So I get 1/4 times the entire quantity of, so negative 2 plus 1 is u to the negative 1 all over negative 1, minus, on the second one adding 1, I get u to the negative 2 all over negative 2, and then that plus c will hang out. So rewriting this just a little bit, 1/4 times the entire quantity, this will be just negative 1 over u. Negative and a negative makes, so the next one's a positive 1 over 2u squared plus c. And my original u was 2x plus 1, so I'm going to bring that into play again. 1/4 times the entire quantity of negative 1 over 2x plus 1 plus 1 over 2 times 2x plus 1 squared. And then all of this plus c. Now I can do a couple things here. I could get it all over the same denominator. I could bring the 1/4 in, but in essence we have the answer right here. So how it may look, you know, in some kind of solution manual may look different, but we still have an equivalent answer. So I'm good enough with that right there.